So welcome once again to our YouTube channel. Again, it's a request to do like and share the video and subscribe the channel. Next question for you. That's the question you would have got today, bachcho. So this is a unique way of giving the a relation, okay, between x and y. Of course, see why I'm saying y, because normal, that's how we write fx, okay, when we have to use it geometrically or use its differentiation or whatever it is, okay. So that's why I said it's a unique way of giving us a relation, which is y into e raised to the power y is equal to x. And what we have to evaluate? We have to evaluate 0 to e integral fx dx. So is there any way? According to me, I don't think there's any way of getting fx here or y in terms of x here. Okay, I tried a bit, but I won't say I tried a lot, but I will say I tried a bit, because then I realized I won't be able to get it. That's what I realized. Okay, then I started thinking something else, and see, the question was actually for differentiable function. I deliberately put as oblique bijective function. Okay, it should be bijective function, because the first way I solved was using inverse of the function, though it was not given in the question, but just to complete the question, just to check whether it can be solved using inverse or not, and then I got the answer also. Okay, and then I thought it's not given, so first I thought, okay, let us add bijective function. Okay, then I thought, why is it given to be a differentiable function? Then I again randomly I just differentiated both the sides, and then I thought, okay, we can do it, and I got exactly the same expression in both the cases. Okay, both the ways. So let's start. So using I will move in reverse order, because first it was actually in original question is given to be a differentiable function. So I will say differentiating the given relation both the sides. So differentiate this relation, of course, both the sides. What do we get? So what do we get? We will get, of course, it's a product rule here. So y into e raised power y plus e raised power y dy is equal to dx. Now what we have to integrate? We have to integrate 0 to e y dx. Okay. So either convert y in terms of x, that's the normal approach, but here in the question the approach is replace dx by dy. Okay, that's what we got. So just replace. So therefore integral is, now limit might be a problem. So y e raised to the power y 1 plus y dy. Now what about limit here? Okay, so to get the limit I will say, okay, put x is equal to 0. So we have 0 is equal to y into e raised to the power y. Now tell me, can exponential be ever 0? Answer is of course not. Exponential function can't be 0 at any point of time. Okay, so exponential can't be 0, so that means y has to be 0. So when x is 0, y is 0, so you got the lower limit. Now what about the upper limit? So I will say, of course, put x is equal to 1. So put x is equal to 1, what do we get? Rather, put x is equal to e. Okay, so what do we get? E is equal to y into e raised to the power y, and here I will say, just by observing it, we know if I put y is equal to 1, you will get e is equal to e, so that means that's 1. Okay, so that's the limit for us here. So 0 to 1 y dy, and that's a very simple integral using by parts over y square into e raised power y dy, and leaving the second thing as it is, 0 to 1. Okay, now by parts, Eilert rule. So a algebraic function y square appears before e exponential function, so it has to be the first function. So applying it, so you will say first function into integral of second function, which is e raised power y, will remain same, limit from 0 to 1 minus limit from 0 to 1 derivative of first function into integral of second function, and plus 0 to 1 e raised power y dy here. So what we will get? So this is, how much is it? See, when y is 1, so this is e, when y is 0, it's 0. So minus 2 times again. Achha, one more thing. So why am I putting bracket here? Because 2 times the integral, so it's minus 2 times 0 to 1 y into e raised power y dy plus 0 to 1 y into e raised power y dy. So these two terms will get cancelled, and you will get e minus 0 to 1 y into integral of tell you I am writing it here, though I shouldn't, but okay, it's okay. Now let's integrate it. So therefore I is equal to e minus, applying by parts again, y into integral of second function limit 0 to 1 minus limit 0 to 1, derivative of y is 1 with respect to y of course, and integral of e raised power y is e raised power y, that's it. So this is again e minus e plus, so that gets cancelled, e raised power y 0 to 1, which is e minus 1, and that's the answer. That's the answer. Okay. Now let's move to the second part. See why I use the second part. I just thought to get rid of f of x. I said, okay, let us replace the second way of doing it. Actually I did it that way as a first method. So let us replace x by f inverse of t. Okay. Now we have a relation. Relation is fx into e raised to the power fx is equal to x. So replace x by f. Acha, dx, what will that be? So dx will be d of f inverse of t. Okay. Now I left it as it is because I can't do anything for that here in this case. So I just left it as it is. So just thought I will consider it later. Maybe I get something which might be helpful here. Now here, if I replace x by f inverse t, won't that be t? It will be t. E raised to the power t, and this is our f inverse of t, and see it got, actually is the same method. Why so? Because then to get d of f inverse t I have to differentiate it, and you get back the same thing by e raised power y d, and so it is nothing but t plus 1 e raised power t dt. So therefore integral will be, so for fx it's t. So t into 1 plus t e raised power t dt, and what about our from here, of course here itself, because see when x is 0, okay, so what is f of 0? So you will say, okay, f of 0 has to be 0, isn't that bachcho? So when x is 0, f of 0 has to be 0. Similarly, so can't we say that t is f of x? So when x is 0, f of 0 is 0, so hence t is 0. And when x is e, we know f of e has to be 1. So f of e is 1, so t is 1. So exactly the same form we got. So I is equal to 0 to 1, t 1 plus t. So I am not going to solve it again. That's what exactly we solved just before few moments. So that's it. Okay, so that's why I decided to have this term added. So it should be bijective function here, this term added, because one approach could be using the inverse of the function also.